how's everyone doing? I feel like I'm off center here. Maybe I am, maybe I'm not. Who knows? But we're wearing the black t-shirt today. Got it back. Black t-shirt day. Got some Monster Energy drink. Who's in the chat? Yep. It's live. Let me know if there are issues. Good morning, Aaron. I might do some 320 to start. Noel! Looks pretty standard. Nice, thank you. Yeah, and we start right on time. Sorry if I ever started. We started like a minute late, actually. Sorry if I ever start like a minute or two late. I'm usually running, getting Quest energy bar and energy drink and processed food, all that good stuff. Yeah, which one do you want to do from there? And we're going to reserve a little bit of time to do some 320s. If you're here for 320, we could do it here coming up soon. So we're in black ring and black this and everything. It's Black T-shirt day. Doing same time, same bat channel, same bat time. Good old Adam West. Same time we say, let's do chapter 5 part 2. Which one should we do from chapter 5 part 2? That's wrong password. I'm getting it loaded up here in the background. Get it loaded up. Woo! Busy day. Busy day. Disk drives have been getting larger. They have terabytes now instead of gigabytes and megabytes and kilobytes and bits and bytes and ones and zeros. We went down in scale right there. It goes after terabyte, I think it goes petabyte, and then zettabyte, yottabyte, something like that. That's the scale of like kilo, mega, giga, peta, yotta, zetta. This gets crazy. PETA, petabyte. So like a petaflop or a teraflop or a gigaflop or a megaflop. Megaflop. That's what happens with movies. Sometimes they make a flop. Wrong quiz. I started the wrong. Yeah. If there's an issue, let us know. I could like cancel the submission. If there's ever an issue, like you do something and it doesn't work, and like, hey Brian, I started this and it broke. I'll fix it. Just let us know. Hey, I started this and it doesn't work. Disk drives have been getting larger. Chapter 5, part 2. Okay, we're almost there. Fun time's almost over. Glassdoor, Forester, speed of cars. 53 men in a downhill skiing competition. We'll go to the main screen, I'll show it. I need to get Word open. Microsoft Word. Oh my gosh. There's Word. There's this. Let's go to main screen. Okay, disk drives have been getting larger. Was that the wrong one? Because yeah, disk drives have been getting larger is a different one. That's chapter 6, I think. You correct me if I'm wrong, but I think it's chapter 6. I guess I'm not off the screen there. I recentered the camera, so. Drink. Mean household income. This one deals with a right skewed distribution. We can see it when we look at the data. Once again, I have all the questions, every single question. So let's take a look. What I'm gonna do is I'm gonna go to my soundboard real quick because it keeps not saving. Where's GoXLR? There's the soundboard. That's Stream Deck. Where's soundboard? Oh, Mubot's not even awake. Mubot, wake up. And I'll worry about GoXLR another time. Here we go. Finding where? Wait, do you see it? Is it like a changing question? Did I miss it? Am I going crazy? So the mean household income. That wasn't it, was it? Hey, Mubot. Mubot, it's time to work. Noel, am I missing this? Oh, is this on the homework? Is this on the homework? I can open up the homework, but I think there's a homework one, right? Which is perfectly fine. I just think it's a homework one. Yeah, and we can do the homework one, so I'll do that here. Sometimes there's a homework one that's not on the quiz, so I think it is. You want to work the quiz? Yeah. And just, so I think I can work that one real quick. NFL data. Yeah, okay, let's do the NFL data one. We can do whatever you guys want. Guys, gals, pals, everyone here. I'm from New York, so when you hear me say guys, it's just me being like, hey guys. That's how I talk. Sometimes when I'm from New York. I am from New York. fine. I saw the NFL one a moment ago. Really? It's like the last one and I went backwards from it. There it is. You can do the NFL one. Let's do it. Okay, let me go to the list here. Our fun is over. Mewbot's awake. He's handing out points. We need to make some new point scales here. Okay, we are at the 8:33 mark, and this is Stat Tool 1, Chapter 5, Part 2 quiz, and NFL data. All right, let's do it. So what you want to do right here is you want to practice using the applet. And the number one thing to do, Mewbot's going to post the applet in the chat. You won't use the applet during the test. You will need to know how to draw the normal model. You can see we were doing this a lot last time. We can actually use these sorts of graphics right here because when you start the test, draw the normal model. You also want to draw on your normal model the percentages like 68, 95, 99.7. And let's actually, I'm going to save this file on my computer right here so we can use it. And then we're going to put, let's call it normal new 2024 fall. Cool. It's now saved on my computer. That saved thing. I know you can't see what's going on right now, but I'm saving it. It's taking an hour to save, and it's now saved. Okay, good deal. We're going to erase all this nonsense, but you should have at least this, knowing how the 68, 95, 99.7 works. And if it won't let you erase it, you just try again. And then you say, you know what, I'll just take this graphic and go to a new sheet, and I'll paste that graphic. That's a lot quicker. Okay, so we have the graphic right here, and you should know how to do this. Now, you notice it has numbers below it. We're going to not write in those numbers right now. We're going to start with a blank graphic. So I'm going to go to my white pen and remove these numbers. You can always have z-scores below this. Z-scores tell you how many standard deviations something is above or below the mean. So it'd be good right here to go and put z-scores of 0, 1, 2, 3. -1, -2, -3. Now what I'm going to do right here is, before working this problem, I'm going to take a screenshot of this. And the reason being is if we do any future problems today, which we will do, this is going to be my standard graphics. Now I can't erase those numbers. So this is what I would at least have drawn when I start the test. If you're starting the test, you want to draw at least this, but you can really go an extra mile. If you go right here, great job, we'll do the 53 men here coming up next. If you go right here, and what number would you put right here? Let's see if you can figure out this number. What percent of area is between there and there? What percent of area is between there and there? What percent of area? Does anyone know? Feel free to answer. Don't worry if you're wrong. Well, 68 is total. That is correct, Noel. 13 is coming up here soon. But think, I'm telling you, the total area here is 68, not 23. Good guesses. So think about the way this looks and what it is. Think about what it is right here. And so if you look at what this is, you can see this is whole thing is 68. So what would one of those blue arrows, what would one of these blue areas be worth? And I'm saying between here and here, and between here and here is how much total? So how much is there between there and there and there and there? 30. Yeah, it's just practice. Don't worry. 34. 34. And then you can go up here, and how much are these blue arrows worth? How much are those blue arrows worth? Great job, Eve. Good to see you here. We're throwing more points. So if 68 is inside, how much is total outside? And then cut that in half. 68 inside, what's total outside? Cut that in half. So what's total outside? And then cut that in half. We're pretending we just started the test, and I would write all this down. This is like the test just started. You can't have work, and great job, Aaron, right there. It's 16 because that's the remaining portion outside. And on the test, it literally gives you the numbers 68, 95, 99.7 and tells you to use those numbers. So you should know you'll know the numbers because they're on the test. So don't try to get these wrong or you can memorize them, but they're on the test. How about this next one right here? This next one right here, if 95% is inside, what is total outside? And then cut that in half. So 95 inside, total outside, and then cut that in half. So what is one of those arrows worth? Because we're saying 95% inside, total outside, cut it in half. 2.5. And now Aaron, or I think it was Aaron who said this, you want to go between these arrows and take the difference between them. So how much is between here, which is the difference between these numbers? How much is between there, which is the difference between the numbers? I think I'm going to erase by pressing this. Let me try it out. Oh my God, I didn't know that. How much is between those arrows, like between here? How much is between there? You want to subtract those two numbers. So how much is between there? Subtract the numbers. So between here and 13.5, Noel, great job right there. You're right. Then we're almost done. How much is outside of the 99.7? Cut that in half. We're almost done, and we're going to use this graphic a lot. So if you're seeing future things, I might even say, go to the start of the video. The first question we did, we wrote this all down because we're not going to do it every time. We're going to use it. So how much is outside of the 99.7? Then cut that in half. Remember, 99.7 inside, this much outside, cut it in half. So how much? Cut it in half. So 99.7 inside, 0.3 outside. Cut it in half. 0.3 total, and then cut it in half. Yep. And one way to check these numbers to make sure you have them correct is I call it riding the rails. Is if you were to be a little person over here and you were to hop on this and ride across this, and you were to go, wee, how much should you get as you ride across that? How much should that add up to as you just like skateboard Tony Hawk style across that? I got those old memes. It should add up to how much percent? How much should it add up to total? 100%. And then we're going to do the same trick right here that we've been doing, the between trick. How much is between this by subtracting the two numbers? So subtract the two numbers, and how much is between there? So subtract the two numbers, how much is between? Subtract the two numbers, how much is between? You just take that number there and that number there, subtract. How much is between? I'll start writing it. Great job, Aaron. You got it. And then the last one is above here is 1.5. And then it repeats on the other side. You could also do things like put the percentile if you want. This is going to be the 0.15th percentile, the 2.5th percentile, the 16th percentile, the 50th percentile, the 84th, because we're adding on the 34 right there. And then this is the 97.5th percentile because 2.5 is above it. And then this is the 99.85th percentile, which means, and this is a huge hint for the test, the area below. I can't state that enough. You know this in my class. The area below means percentile. The area below. Okay, you know a teaching to the test moment. Means we're teaching to the test. Okay, so with this, let's go look at the question. Now solve it. According to the normal model, what percent of receivers would you expect to gain more than 2 yards above the mean? So according to the normal model, what percent of receivers would you expect to get more than 2 standard deviations above the mean? So what's the answer to this? What percent of receivers would you expect to be higher than 2 standard deviations according to the normal model? It's very easy to see right now. According to the normal model. What would the answer be? 2.5. You got it. You just go right there and you say, well, above right there. So we got it. It's just you follow the arrow over. You say, okay, above is 2.5. We've already done our drawing. And so that's according to the normal model right here, 2.5%. From these data, what does it mean? Well, if I had 1,000 students and I expect 2.5% of them to ace the test, how many of them would I expect to ace the test? If I had 1,000 students and I expect 2.5% of them to ace the test, how many of them would I expect to ace the test? Does that make sense? If I had 1,000 students and I expect 2.5% of them to ace the test, I'd expect 25. So why not do the same thing here? If we have a total of, so 2.5 are expected to ace the test out of 1,000, so we would say, well, 2.5% of 1,000. So now we have a total of 508 receivers, and I expect 2.5% of them. So what should I do? No, great answers. What should I do with this 508 if we expect 2.5% of them to be above this? If I expect 2.5% of them to be above this, what should I do with this 508? Think about what I just did and be like, well, if you expect 2.5% of that, then what should I do with that mathematically? So the key is to know what to do mathematically. To say if I expect 2.5% to be over here, then we have 508, and I expect 2.5% of this 508. It's like, well, I expect 2.5% of the receivers out of the 508. So what should I do mathematically over here? Yeah, exactly. go, there you go. Multiply it by 0.025, 2.5% of that. So it would be about 12.7, round to the nearest whole number, becomes 13. Does that make sense? So it's like, well, I'd expect about 13 of the 508 receivers to get above, and this will be 2 standard deviations above the mean. So we go here to the mean of 253.762, and then we add a standard deviation. We're going 2 standard deviations up. And notice we go to the mean and go up a standard deviation and then up a standard deviation again. So this is 2 standard deviations above the mean. It says round to the nearest whole number. And that's it right there. That's just 2 standard deviations above the mean. To make the problem simpler, if we change the numbers and we give it a different, easier context, it's like they're saying the average person in the NFL gets about 200 yards with a standard deviation of 300, and you're just going up 2 standard deviations. Those aren't the real numbers. Does that make sense? Like, it wasn't a mean of 200 and a standard deviation of 300, but if it was, you would just go to the mean of 200 and go up 2 standard deviations. So you're just going to mean, whatever the mean value is, and going standard deviation over to the right. So that's 2 standard deviations above the mean right there. So please stop me if you have questions, but drawing it out can really help. And we just went to the mean and went plus 2 standard deviations. Now, here's a huge problem, especially I mentioned the applet earlier. And if you put these numbers into the applet, you're going to see something really weird with this data. What do you notice weird about this data? We'll enter in kind of close numbers. The model goes what very quickly? I think this is yards you get over a season in the NFL. The model goes very, very what very quickly. And it's this is yards you get over a season. So think of like a season in the NFL. Would you be like, I don't know about that. I don't know about that. What do you notice about the yards? Like if you're thinking like typical NFL players in their career and like yards in a season. Notice anything weird? Basically, this is saying I could play in the NFL. Because I'd probably be down here somewhere. They hand me the ball and I run backwards. I said, no, I'll help you out. They say, my own team's tackling me. It's not, and Noel got it right there, the negative yards. Because it's possible to get negative yards in a season, like if you get sacked as a quarterback or something like that. But over a whole season, you're probably not going to have negative yards. And we're not going to see a lot of the players, like 16% of players are getting negative 500, negative 50 or less. So we wouldn't expect to see a large portion of players getting negative yards. And that's because the data is probably right skewed. It's probably more accurate that the data in the NFL, you know, there's like a bunch of players getting a typical amount of yards. And then you've got the superstars. So this is like your typical players inside of here. You got low performers, typical players, high performers, crazy people, like in terms of yardage, and then like Hall of Famers and people like that on the far end. And so it's probably right skewed. So the distribution is probably skewed to the right. So the normal is not appropriate because there's probably people getting very high amounts of yards. Does that make sense? And so really good question right here, going over what data might look like. And do they show you? Oh, yeah, the data is not normal. It's very right skew. And you know it. You love it. We can't not draw him because we know when we get to the test, instantaneously, right to the high, left to the low, whatever way the monster man's tail goes. No one gets skew wrong in my class. Nobody's going to get skew wrong. Right to the high, left to the low, whatever way the monster man's tail goes. So good stuff right there. Good question. We're going to do the downhill skiing one next. So we've already got some drawings to help us out, and we can erase stuff. 53 men on the downhill skiing competition. This is probably my favorite quiz of the semester. I'm not even joking. People hate this quiz. I love it. It's a concept that is very important to statistics that if you learn will really help for the remainder of your college career. It's how data is structured. It's using z-scores. It's just understanding if something's odd. So how do you understand if something's odd? You give it a z-score. When do you give z-scores? When data is normal. How do you know if it's normal? You check certain things like look at the histogram, look at the normal probability plot, and do a goodness of fit if you want. So let's do this question right here on the downhill skiing competition. It's a little similar to the last one we did. Let's check it out. The mean time was this. The standard deviation was this. If the normal model is appropriate, what percent of times would be greater than this? So what you want to do right here is you want to go to the applet. Let's pull up the applet. And when using the applet, what is the first step when using the applet? What is the first step when using the applet? So pretend you've pulled up the applet now, and you could get pictures of the applet on the test. What is your first step when using the applet? Okay, you got the applet up. What should you do with the applet on the screen first? Which I failed to do yesterday. So don't be like Brian in that instance. What should you do first? Mean and standard deviation, bingo. Great job, Noel, right there. We're going to put in the mean of 103.90. And then after you do this, fill in the mean and standard deviation, the context of the curve will change. And you notice the curve has changed down here on the bottom to have the mean and standard deviation. And then you ask, what am I trying to find? Should I find an X using a percent? No, we're trying to find a percent. Notice how the answer here is a percent. So find the p-value or percent using X. Now we're going to go right here and say greater than 108.61. If you notice, this is a little bit below 2 standard deviations, and we drew our drawing earlier, and we saw that this up here is 2.5% of the curve, so it makes sense that it's more than 2.5%. Noel, does that make sense? And everyone here, does it make sense that if you see where the second standard deviation is at, it's right here, meaning that this would be 2.5%, so obviously this is more than 2.5%. And we can look at our drawing we did earlier to confirm this, to see we're on the right track, because our answer right now is somewhere here, graphically speaking, and we already did an answer just previously where it was 2.5%, so this has to be more than the 2.5%. That's why it's very close to 4%. We would not be expected to know this exact answer on the test. We'd be given a picture, or we could deduce it using kind of between 16 and 2.5, because 16% would be above here, as in if I entered 106.5, that'd be about 16%. And I know right here, the 109.2 is about 2.5. It's going to be 2.3 or 2.4. There it is. But when we do the empirical rule, we do 2.5. But once again, we're entering in 108.61, and it wants it as a percent. And so we're going to enter into one decimal, 3.8. Can you show the data you input in the applet? Yep. So we're entering in greater than 108.61 right here. We're rounding to 3 decimals. We're putting in the mean and the standard deviation. I'll pause on this screen. This currently shows everything you need to enter in, where the question says the mean was this, the standard deviation was this. There it is. We are solving for a percent using X. A lot of people forget to click this button, because now when we enter in the value of X, it's greater than 108.61, and then we have this right here above, and there it is right there. Does that make sense, Noel? Let me know questions, and enter the number in right here. Make sure it's rounded to 3 decimals. You can change the rounding up there on the applet. So really good stuff, and huge thank you to Adam Spanbauer who made this. Amazing applet, looks awesome, and I had tried to make it, but yeah. It's above, yep, because it says greater than. So when it says greater than this right here, we're going to go to the above. The test might show you like below or something, but you want to know we need to do above because it says greater than right over here. The greater than is the key that we're doing above. What is the actual percent? We no longer need the applet now. So the actual percent is what we observe in the data. So you have to go to the data. Here's the data. Remember that there's 53 men. The question states that. So it's 108.61, I believe. Let's make sure I'm correct. 108.61 would be right here. 108.61. How many men had a time higher than 108.61? How many men had a time higher than 108.61? How many men had a time higher than 108.61? So you just have to look. 4. Out of how many? 53. So there's the answer. It's going to be about 7.7%. I'm going 7.7. 7.5, close enough. My person might have been mad. 7.5%. The one that is the time they said right here. How many actually, if you look at the good question right there, Noel, good questions. It says how many men had a time higher than this. If you see right here, I can't get it both on the screen at the same time. There we go. If I put it here, it says how many men had a time higher than 108.61. And so it's saying, well, in actuality for the data, what percent of men were higher? So there's 4 men out of the 53. And the question states here the 53, or you could add up how many men there are right there. But the time right there is the time they gave. How many men have a time higher than this time? And you can see the 4 men, if we put a line right there where the time would be, because they are put in order. And good question. Good stuff. Keep asking those questions. Why do these two percentages not agree? Well, they kind of get into it if we view the data. So let's view the data first. You can do this in jump, but I want you to see this. What numbers of like, is 108 here a lot? Is 103 here a lot? Is 102 here a lot? Is 101 here a lot? Which of the 10 something is here a lot? Where do you see a lot of 10 somethings with this data? Where do you see a lot of 10 somethings? Is it like 111 is very common? Like you see 111, no, we don't see 111 a lot. Do you see a lot of 100 flat a lot? 100, no, I only see 4 of those. 102, 102 is here a lot. 101, 102, 103. So what might that tell us about the graphic down here? We see a lot of 102s, 103s, 101s. What might that tell us that we see a lot of 102, 101s, 103s? Because we see a lot of 101s, a lot of 102s, a lot of 103s, and then it kind of dwindles off in the higher values. Exactly, that's where the peak of the distribution will be. That's the modal area of concentration of data where the most frequent data is. And so you can kind of get an understanding of how to look at it, that there's like this 111 that makes a gap right here. You see how there's like no data at 110, and this goes into the basically 109 bin, and then this goes into the 111 bin right here, and then there's this small gap because there's no data right there. So we can see the high peak right here and a little bit of a bump there, and this is more uniform. That's peaked at 106, and this is peaking here at 110. So very clearly the data is what skewed. We'll go back to that question we missed, but the data is what skewed. Very, very clearly, the data is what skewed. You know him. You love him. He's back. Right skewed. Kiana right there got it for the points. We know right skewed. It's a monster man. Monster man. Right skewed over here. Right to the high, left to the low. I realize some people might not know our saying of right to the high. We're talking about the high side of the numbers to the right, left to the low, low side of the numbers, whatever way the monster man's tail goes. Right to the high, left to the low, whatever way the monster man's tail goes. PhD students have used that. So it's definitely right skewed. That answer that question. And then think about this. If we were to say the data is not normal, how would we say that without saying the word normal? If we were to say the data is not normal, like why are these two percentages off? The question used to be, do you think they agree? And I was they actually changed this question a few years back. Because I was like, do they agree? And then I think they were finally like, okay, why do they not agree? Because they're going for that. What's another way to say normal without saying normal? So they have the answer here, it's not normal, but they didn't use the words normal. The normal model has 2 characteristics about it, which they list. What is another way to say it's not normal? Good answers, Aaron. Uniform is flat. Now, it's true it's not uniform. No, good answers. You're right. It is not uniform. What we'd be looking for right here is it's not unimodal symmetric. And I wish they just said it's not normal. The normal model is a unimodal symmetric curve. Our curve is unimodal, but it's not unimodal and symmetric, which the normal model is. So I wish they just said it's not normal. Maybe it would have been too obvious then, but the problem with this is it's not normal. Let's do that one next, Darren, and thank you so much. So the problem right there is it's not unimodal symmetric, and so that's the problem. Unimodal symmetric is another way to say normal. And it is unimodal, but it's not unimodal and symmetric. Tricky, my person. You don't do that to us. My gosh. Let's do that IQ question right here. We almost got the same numbers. This one's going to be an applet question, Aaron, so have the applet ready. Someone, for 500 points, have Mubot drop the applet in the chat. We'll do a few of these because I really like these questions too. Who knows how to get Mubot to tell you where the applet's at? Because during class, we might have to do that, or Mubot, and we'll use the applets for later things in the semester, but someone have Mubot drop the applet as I do this. Yeah, that should do it. He responds to a few different things, like exclamation applet, or even just applet as a word, because I started changing how I do commands. Tell us about that applet, Mubot. If you won't, let me see if he responds to that, and I'm going to... You know what I'm going to do, Aaron? Real quick right here as we start this question. I'm going to add that as a command. Where's my search commands? No, here we go. It's just here. Okay, edit. 2 seconds, Aaron. It's going to be exclamation applet 2. So that way we can do that. Plus command, try that command now, Aaron. So I'm making it so I have all the commands. I always forget the command because I've done it 10 different ways. Okay, there we go. And then I think he has app in here. Yeah, I just did it. Okay. Yeah, there we go. There's like 50, there's 5 different ways you can do it now. Here, I'll show it. There's 5 different ways Mewbot knows that. So it doesn't matter. It doesn't matter which way you do it. Mewbot will do it. Okay. There's Mewbot in the background. Okay, so we're good to go. We've got the applet on the screen. Thank you, Aaron. I'll drop you another 500 points. And we're going to pin the message from Mewbot. And there's the applet. And once again, click the applet. First thing we enter into the applet is what? You know it, you love it. I'm going to get the screen situated, but I want you to tell me what you should enter into the applet first. What should you enter into the applet first? You have the applet up. You're like, how do I use this? What do I do? Mean and standard deviation. Now, what I'm going to do is I'm going to go beep, boop, beep, boop. And I'm going to try to solve these answers. So I'm trying to solve these answers by guessing. This is a practice using the empirical rule, using my knowledge. If you don't get these right, it's all right. I'm just taking guesses. So I'm thinking right now, I'm going to tell you my process. Don't worry. If you know how to do it and use the empirical rule, follow along. But we're going to the next section where we're going to solve the answers in a few seconds. 15th percentile is near the 16th percentile, which is near just a little bit below 1 standard deviation. That'd be about 19 below. We're going to go 80.1. Why not? 97th percentile is near the 97.5th percentile, which is 2 standard deviations above, but it'd be a little bit below. So we're going to go 35 above, which is a little bit of less than 2 standard deviations. 35 above is 134, and I'm going to go a little change right there. The IQR is 1 1/3 standard deviations. So a third standard deviation is 24, round to 1 decimal. It usually goes a little bit less, so 23.8. We check the answers, and we got 0. Let's get the actual answers. To get the actual answers, we'll see how close I was in my guesses. We're going to enter in the mean and standard deviation first. 99 and also 18. Now the curve shows the real numbers on the curve, no longer the z-scores. We are trying to solve for an x, finding a p-value. We're not solving for a percent, which is noted here as a p-value. We are solving for the value x on the curve for somebody's IQ. Now, whenever we do percentile, we're talking about the area what to where we're at. Whenever we do percentile, we're talking about the area what to where we're at. Test question. Whenever we're talking about percentile, we're talking about the area what to where we're at. Just like we do earlier, percentiles, which are these numbers here, below. So when you score in the higher percentile on the test, like the 99th percentile, that means 99% of people scored lower than you. So to do percentile, always do below. Notice how the 95th percentile right now, I'll disappear so you can see it. The 95th percentile means 95% of people are below this point. So percentile is always the below button. So if it asks for a percentile, we are going to do below. Notice how the 15th percentile would be on the left side of curve below the mean. So all we do is enter in the 15th percentile. And I was kind of close. Dang it. If I had just typed in that, I would have got that answer correct. I was off by 1/10, and I got the first answer super close. So I'll pause here. Please let me know if you have questions. This is the 15th percentile, which would be below the mean and very close to where the 16th percentile is at. And remember, I was doing that in my head using the empirical rule because I know the 15th percentile is a little bit to the left. And I want to show that here visually. Does everyone understand that the 15th percentile would be somewhere between here and here? Does that make sense? The 15th percentile is somewhere right about here. And if you look at the graphic we have, it's going to show that. So maybe I can put this on the side right here, just so you can see what I was doing in my head because I've done the empirical rule a lot. The 15th percentile is going to be somewhere over there. And then if you think about the next one right here, it said the 97th percentile. And that's why I went right over here, because that's where the 97.5th percentile is, where 2.5% of the area is above it. That's why I was saying 2 standard deviations, and that's what I was working in my head for the 97th percentile. And there's where the 97th percentile is. Yep, exactly. And make sure it's below, Noel. Great job, Noel. This one I was a little more off on. Not a horrible guess, but a little more off on. So 132.9, and we should have that one correct. so close. Should I have just done 24 on this? Yeah. Should have just done 24 and I would have gotten that one correct. So this is now correct. This is the 97th percentile. The 97th percentile is going to be a little bit below. Look at the drawing we have. If you look at our drawing right here, you can see I've marked it in the yellow right here. You can see it marked here. I don't have the numbers below like they do, but that is a little bit below 2 standard deviations. Try doing your drawings by hand. I can't state how much that helps. If you can do the drawing and then you go to the applet and you confirm the answer, you'll be like, yeah, that's exactly what I drew. Because the next one right here, think about this. The inner 50%, excuse me, because this is the IQR. The IQR is going to look something like, there we go. Because it has to be less than what? The IQR is going to look like what? Because it has to be less than what? It's going to look more within 1 standard deviation because it has to be less than what's shaded in the middle. Because the IQR is the middle 50%. So it has to be less than what? So this is visually what I'm going to be looking for on the graphic. I'm going to be looking for something visually that looks like this because it has to be less than what? So for the IQR, visually, I'm going to look for something what? It's going to be within the 1 standard deviations because it has to be less than what percent of the curve shaded. Because 1 standard deviation goes from -1 to 1, encompassing how much area? So basically, we're doing the empirical, the something's 95, 99.7. It has to be less within the first standard deviations because within positive -1 is the middle. And I clicked middle. If you didn't see, I clicked between. The middle 68% is within -1 and +1. You basically see 1 standard deviation there. And then the middle 50% is going to be more compact. Once again, take a look at how I was doing my drawing over here, where I went and actually we can control Y this back here. If you notice, my drawing looks a lot like what I have over here, the middle 50% of data. And then I did the exact same drawing over here, and it looks just like it. The more you can draw it out over here and know what you're going to be looking for over here, very important. This spot right here is the what spot, and this spot right here is the what spot. Like these numbers right here, the ones I've highlighted in pink right there, those represent what and what in notation. This is what in notation, this is what in notation. Like, what are those in notation? Because this is the what percentile, and this is the what percentile. If you don't know, feel free to say you don't know, but we're going to be able to solve the answer here in just a moment. Think about the percentile they are. Like, what percentile are they? Because what percent of area is below here? What percent of area is below here? 50% inside, 25% above here, 25% below here. So what percentiles are those? And then how do we abbreviate those? Close. So this is the middle 50%. And if 50% is in the middle, that leaves 25% up here and 25% down there, making this Q1 and making this, well, not where that line I put, making this Q1 and making this Q3. Does that make sense? Because it's the middle 50%, and if 25% is below here, then this is Q1 because it's the 25th percentile. We could even do this right here. Don't change your answer yet. That's the bottom 25%, that's the top 25%, and then we want the middle 50%. So what should I do with these two numbers right here? I'll start doing it, but think since this is Q3 rather, that's Q3, and this is Q1, what do you do to get the IQR? There you go. And so it should accept that. Q3 minus Q1 is the IQR, and that's how you get the answer. It should accept 24.3. It was a very nice, should accept that. Yep. Wow, I should just guessed 24. I wonder if 24.1, are they just doing like nice, yeah, there you go. Yeah. You're not really meant to guess these, but I've done these a lot, so I understand how to use the empirical rule. And that's why we have the empirical rule, because you can just know it at all times and take educated guesses at what the numbers would be. So the applet gets you the exact decimal places answers, but the empirical rule is what you carry with you at all times in your head to be like, well, it's about this because about this percent of the data is between here and here. We could do another IQ one here. I do like these questions. And so this is version 1. And let's do the next one. Stat Tool 1, Chapter 5, Part 2 quiz. So use the normal model, the normal model. And then I'm probably going to switch to doing some new stuff here in a moment. This wants percentile on the curve. So to get percentile on the curve, we're basically going to do the same things we've been doing. And let's check that out. So we're going to get percentile on the curve. To get the percentile on the curve, once again, you want to enter in your mean and standard deviation. Ooh, no. And 75. There we go. And the percentile, once again, is the area below. And the 59th percentile is a little bit above the mean. Economics, yeah, let's do that one. I'll just answer this one really quickly right here. 94th percentile. And then ask the IQ. This is literally the same question. This is literally the same question. It's just with steers. We're going to do glass doors, then we're going to switch over to something a little bit different. And between, and I need to subtract these numbers. That's 101, I believe. Did I do it quickly enough? Got it. Okay, let's do glass door. Let me switch questions. Or switch topics. Glassdoor. Here we go. Okay, let's do the Glassdoor question. 4303. We did that question in 30 seconds? Sure. No way. I must have marked that wrong. Check that later. Let me hit save on this because I forgot to save one off stars. Okay, let's look at the histogram. Looks pretty what, Noel? What do you think about this histogram? If you saw my reaction to it, I would say, what about this histogram? Sure. And it's the log version of the data. It looks pretty normal to me. Yeah. Whee! So that looks pretty normal, unimodal symmetric. Good stuff. It's 95% within plus or minus 2 standard deviations. That's about as normal can get. According to the normal model, what percent of CEOs would you expect to earn more than 2 standard deviations? So once again, we have our graphic from the first question we've drawn. What percent would you expect to earn more than 2 standard deviations above the mean? What percent would you expect to earn more than 2 standard deviations above the mean? So once again, you want to go to the first question we did. We drew this all out. It has a lot of information. What percent of CEOs would you expect? And you could write the numbers on here, but it shows the answer if you just look 2 standard deviations above and then percent above 2 standard deviations. Exactly. And that won't change according to the empirical rule. If you use the applet, it will give you a more exact answer, but 2.5 is the right answer according to the normal model. So 2.5 is going to be the answer. Is that the percentages you see for these data? Yeah, it looks close because they're showing it in the second graphic. So this is, if we go to 2 standard deviations above, 1.07 plus, it's 1.59. This is a different data set, right? It looks about right. It looks close. They're trying to trick me. I'd say yes, because it's mostly unimodal and fairly symmetric. So they're trying to trick me. Now they're redoing it, which is a bit ridiculous. Now let's draw the sample of 30 CEOs from the log data. We drew 1,000 samples and found their means. The distribution of means is given above with standard deviation of this. Yeah, I mean, when would we apply the empirical rule? When would you put the empirical rule into use? I'm a little worried about question answer B. Don't answer yours yet. I think we're pretty good. When would you use the empirical rule? They're just asking, can you use the empirical rule here, which is the 68, 95, 99.7. So can you use it, and why or why not? Now it would change the mean and it would change the standard deviation technically due to the central limit theorem, which we haven't even covered. They're not asking about that though. But you can see it still looks what? The question basically is, when do you use the empirical rule? And the answer is when data is normal. Yep, unimodal symmetric, and that's normal. So unimodal symmetric, as we've covered in other questions, is another way to say normal. And we should get 100. We did. A little tricky on the first one because it's not like, it's normal enough, I would say. That's normal enough. That's super duper normal. Once again, we want to see that it's basically normal, and we could use a QQ plot or normal probability plot to analyze that, but it's basically normal, and the more normal it is, the better we can do. So good stuff. I'm gonna do a little bit of help for 320. So if you want to see some coding, hang on, let's do it. You're welcome, and great questions, everybody. Okay, let me get UTverse. UTverse. There's like a new UTverse. You're welcome, Aaron, and thank you, everybody. Really good questions today, as always, and really good stuff. Okay, I got so many untitled documents. Let's see here. Okay, I'm gonna try to do a little bit here. BAS 320. Making shiny apps. Okay. New chat. Okay. Let's go over here and check out how to make shiny apps. Let's do it. So this is a shiny app I made because my family does their fantasy drafts offline. So this is my shiny app right here. Change that size of that UT. Wait up. Here, look at it. Power T, however you want power T to be. Be very careful. Gotta look a certain way. I'm sorry, UT, if I don't have it proper. We can add these to other teams as though they're getting selected. We can make an amazing team right here. We can sort by position or rank, all these different things right here, and take different players. And then we can also see right here the top 3 by position. My team currently, my team needs. I need a wide receiver and a running back. So let's go over here. And I don't have my search. I think I updated it afterwards. So I usually have a search menu on here. My updated version on my computer has the search menu where I can type in a name, team needs, projected points right here. There you go. This is the older one, yeah, because I have other things in my new app. But I can also zoom in, and I wish it would show me which player I picked. I should have done that. Like, it should have highlighted which player it was. And you can see the projected points over the full season. This all comes from a data set. So once again, my need, the reason I created this is because my family does a draft over the phone. So everyone's just got a list of people and they're crossing them out. I can just see who the top 3 players are by position. Just be like, oh, let me look right here, and let me go to the average rank right here, and be like, oh, wide receivers still got Tyreek Hill right there. You know, that's, yeah, got to draft him. And you can see like the average rank and all this good stuff right here, and who's gonna win. I mean, who you think's gonna win? I'm 1-1 this season, so I got 2 top tier quarterbacks. I chose a quarterback like round 3 and a quarterback round 5, I think. I did some iffy stuff. I want to trade later. Mid-season, I want to do a quarterback trade for like a good wide running backs is where I'm stressing right now. I should show my team. I wonder if, and then we'll get to serious stuff. Let me see if I can log into fantasy here, and then I probably can't because I got to like password and everything. Ooh, if I can do that, I'll show it. So anyone who cares about fantasy, I'll probably have to post it on the Discord because I'm not logged in on this computer. Anyways, this is the power of making a shiny app because it helped me with my task and made things a lot easier so I can do what I want to do. So what are we doing this week in BAS 320? We're making a shiny app for a company to work with data. So really, I don't expect you to be a pro in this, but we've had people come in for office hours for like an hour, and then they make apps that I was like, I didn't even expect you to make this much or this good. And then they're like, well, I want to do more. And I'm like, yeah, do more. It really comes down to prompts. And I put a prompt, and prompts are what you give AI. So we're going to go over here to online. I'm going to go grab the prompt I gave. And I don't know if I ran my own prompt. I wonder what my prompt will give. We're going to the prompt that I gave to the AI, or I said would be a good prompt. And you can share your prompts on the Discord. I said, you know, share a prompt, tell people what the prompt's going to do. And, you know, if people are stuck, give prompt advice. So we're doing a little bit of help this week among the class so people can share and give advice. And let me go down here to the, I got to move around assignments, shiny dashboard competition. Here we go. Where's my prompt? Man, I wrote a lot for this assignment. It's funny, I try to like write so little and then I write a whole bunch. Okay, there we go. Here we go. Here's the prompt I gave. Let's see what it gives. So it wouldn't be bad to start out with this. Man, look at all this. Woo! It's going to fix that. Okay. It tells you kind of what's going on right here, but we get this, and we're going to copy. That should be the copy, right? Copy. Copied. Then we're going to go back into R. Now, here's the problem. The first thing you see right here is a bunch of things that you might not have. You want to run these slowly at first. See, it says no shiny dashboard. On this computer, I don't have this. Go down here to the bottom and do install.packages. I do it here on the bottom because we're never going to run this again, because once you install it to your computer, it's installed and you're good to go. I don't even know CSS loader. CSS is code right there. Because like I said, I don't know that, so I don't have it. So when I saw that, I was like, I've never seen that one. I was expecting to load it. So we're good to go. And now we're just going to run these again. Doesn't hurt to run libraries twice because I forgot to run the other one. And I have an older version of R, not the end of the world. This is going to store a UI. UI stands for user interface. It's that cool dashboard thing you saw before. It's like the screen of your phone. Think of a UI as your phone's screen. Now the server is the phone's electronics inside that push everything out to the screen. So UI stands for user interface, the things you interface with when you touch your phone. Got a little Batman right there. And then also Capstone coming up. And then the server is the inside components, that is what is running it and pushing that information out to the UI, so you get all the nice buttons you can touch. And so we're going to load the server. This stores the server object with its inputs and outputs so it can kind of communicate between the UI. And then this right here runs the Shiny app, this code. Here's our app. Let's see how it looks. Okay, yeah. There you go. Here, activate. Ooh, buttons. Ooh. There you go. Looking nice. Make a Control Plus right there. Make it bigger. Now the problem you run into, and I don't want to do too much, but you notice we get something right here. We get cool interactive. Also, if you want to, one thing I would suggest is if you look through for where cool interactive is, I'd bet $50 right now it's going to be inside quotes. And there it is, cool interactive dashboard. So we're going to go right here and change this and just say company Shiny app. Now don't call it this. Whatever you want to call it's fine. I'm going to hit Control A, Control Enter to run all the code. See, it says company Shiny app. Pretty much wherever there's text, it's going to be in quotes for a string. So you can make it say what you want. We've also got the skin blue, and I'm going to go to the skin. I'm going to try this. Hashtag FF82, not DD, FF8200. Run it again. It's mad. And then look, argument should be one of the following. No, I'm going to say orange. Where's my set? I'm mad. There we go. No orange for us today. No orange. It's actually got icons here, which is kind of nice. I like that. You can add the icons. Is it using awesome icons? It's using just icons. And you can see dashboard. I think you can, let me try Xbox. You can look up a list of these icons. Yeah, we got Xbox now. I've used the icons before. So there's the Xbox icon. You can maybe even ask it for a list of icons, but I bet if we type icons for Shiny dashboard, the biggest thing is I just know what's possible. And knowing what's possible means I can just go to different things and choose what I want a lot quicker. And here is, these are different things. Yeah, there's so much. I just know about the possibilities. See, we're doing all this right here. We got all of it in moments. Ooh, these are, they're called boxes, I believe, right? Pretty sure those are called boxes. I want to add those. Okay, let me see. They got the code right here for this. Pretty sure those are called boxes. I'm gonna add some of those real quick. Widgets. Okay. There's names you got to remember. Okay, let's go right back to our app. We're going to lose a few things here because I'm doing it here. You could also tell UTverse to change it, or OpenAI, whatever you want to use. I'm going to say I am working with a data set. I don't want to do too much, but you can see, just ask it questions. Say, here's what I'm doing. Data set called Survey 10 from a package called Reg Class. Can you see this data online somewhere? Do you know about it? The variables it contains? If so, tell me 3 facts about it. Okay. This isn't going to help me with the app. I just want to see if UTverse. Ooh, variable types. Okay, well, yeah, there's numeric. It's not really specific. Show me the structure of the data. I need to know you know the names of the variables and also information about rows and other facts. Give me specific facts. I know office hours is about to end. Yeah, second question 5. Yeah, which one is it? I can find it for you. Now it's telling me how to find it. Ooh, wait. No, those are not real variables. There's not 100 observations. This is wrong. Okay, it's got it wrong. No, it's coming up with random stuff. That's bad. You imagined that. It is right on how to do this right here. It is correct. It's telling me how to get all that stuff. It doesn't see the data. So you gotta be careful because now could probably work. A Forrester shows. Yep. And I can find you that one, Noel. Let me find you that one, a Forrester. Actually, I think we did it like last office hours. I'll find that really quick right here. Forrester live office hours. We might have done it too. Oh, it's the previous one, right? Forrester. It is imagining things. Part one. Found it, Noel. I'll drop the link for you, Noel. Copy video current time. So with the histograms, is it, let me know if it's this right here. That's a Forrester measured chapter 5 part 2 quiz. Let me know if it's that, and we'll check for other things. Okay, I want you to add boxes to these tabs that do statistical analysis in the bivariate fashion that someone would need to do for the survey 10 data frame. Make sure that there are drop down boxes for the types of, for the I might stop. I don't want to do too much because I've already done a good bit. It's about knowing what's possible and asking questions, because you have to know what questions you can ask, which is the hardest part. And you have to know what you want. Tree diameter? Let me try to find that right here. Knowing what's possible is the key to being able to do things. Because if you don't know how to speak the language, then you don't know how to, ask the questions. But also think about what we've been learning. So for 320 right here, we've been doing Pearson correlation, Spearman correlation, mosaic plots, scatter plots, side-by-side box plots, difference between means, difference between medians. So asking it to incorporate those ideas. This is basically you're having a conversation with the AI and asking it, oh no, it broke. You're having a conversation with the AI. Redo that output for the chunk of code. The conversation is about what we're doing in the class. I mean, heck, if you upload all the notes or something and say, hey, I need an app that does something that does these things. So I always love seeing what students create when I put a little bit of ambiguity into the world, because then you see some imagination. We ourselves do the hallucination. I'll copy it. Ah! There. Fixed itself. Fixed. Give me my code. Stop talking to me. I'm so mean to AI. I'm the first to go when the robots take over. I am the first to go. It's rather bad. There's a robot over there. Mubot is gonna... If Mubot ever became sentient, I'll be in trouble. Woo! What we got? Uh-oh. Uh-oh. Okay, so something, it looks like when that code was going together, it broke. Error, unexpected, string constant. Looks like there's an extra quote on that. Unless something, this label whole thing right here is acting, so we're going to select ID, am I going to have to fix this? Oh, man. Oh, here it is. Yeah, this has got too many quotes. It's got an extra quote, I think. Literally just tossed an extra quote here. I think that's breaking it. Because choices should be... That's a function, right? That's an argument right there. Man, I'm glad I didn't have to code this. Okay, let's try it now. I think it's breaking on another one. Oh, it's the second... Yeah, this also right here has too many. The label should be a function. Cat. Okay, if you look at the structure of this should have a quote right here. And then the label. Okay, this should be that. That looks. If you look at the structure, this looks like this. This looks like this. That looks right. Okay. I could put it back into AI and ask AI to fix it. This is where you should message me. What? Is it? Where else did it call survey that? Did it call my survey like that? All weird? No. It's survey 10. Wow, that broke right there. Is it still breaking on this? I got a few minutes right here. It's saying it's... Is it the parentheses at the end? Man, this code is this right here. I'm gonna tell it this is broken. Fix this. Because I'm trying my damnedest. Okay. This is broken. I tried to fix it. I need you to make sure it works with the code. Okay. There we go. Okay, it's actually redoing the whole thing. That was towards the end of the code. Line 58. Ooh, that doesn't look. Ooh, that no. Ah, what happened to it? I think it's where the code went wacky. I hope it doesn't do that again. Yeah, no, that is not going to run either. Let's hope we could eliminate some of the tabs. We're running up on time right here. Oof, it did it again. It's breaking on tab 3, so I could hashtag out some of that code. We'll see what it did. That is either, look at the label thing. The labels, the strings are looking weird. So we might hashtag out some of that. And UTverse, yeah, I still love UTverse, but you're gonna give me a little trouble right here. Eee, this is still outside the string. It looks like it. See, I would never be able. I mean, I could code that stuff, but it would take me a long time. Code it without errors like this. It looks like it wants this inside of the quote. Then label shouldn't be there. And that's removed this. Still breaking on that. Okay. I'm gonna go grab this. I would go to OpenAI right now. Error, unexpected closure, unexpected opening. So it's saying there's an unexpected open. Oh, God. I'm clicking on the bars to see where they open and close. What tab is this? Tab 3? Well, you know what? Tab 3, you're just going to have a name, tab 3. Tab 3 is going to be called tab 3. And tab 3 is just going to be all nice and pretty here, called tab 3. Okay. Unexpected closure. That one right there is mad about that. Unexpected closure right here. Unexpected symbol in server. What? We'll see if this. Oh, it's because it didn't close. That ran. No, what is going on with my code? Oh, this isn't closed either. No. Why? This is a broken mess, UTverse. I gotta go class a moment. This is a broken mess. You must fix it. Oh. I took away a lot of the tab 3 code. Like all tab 3 is just a blank tab right now, or should be. I'll worry about that later. We'll see if we get any analysis in here. Then we'll run down to class. It's a conversation. It's a conversation where sometimes you get a little bit, you feel it. You feel the conversation. That tab 3? Stop it! I don't want all that. Oh, don't break right there. Don't break. So literally what I'm going to do, hopefully it does the rest. I'm going to try it here. I'm going to try loading this in. Tab 3 is just a mess and a half. Let me say re-output this, but as 2 chunks with no tab 3. Give me a server and UI chunk. Okay. No tab 3. That should save us from it exploding. And because it always goes crazy on tab 3. There's my cool dashboard. There's tab 1. There's tab 2. Tab 3 gone. Here's what it's putting into tab 1. There's the contents of tab 1, bivariate analysis of numeric variable. Cool. Selecting the variables inside there, select inputs. So we have selections for the inputs. We have an action to analyze it looks like. Then we have text output right there. Verbatim to input text output. It's going to show the text. And analysis 2 is categorical numeric. Good stuff right there. I don't even know what kind of analysis it's doing. Hopefully it has it. That's ooh, okay. We got the UI. UI did not crash. UI did not break. The server is of course going haywire. We might have to re-ask it to do the server, but we'll see what that does. The UI, the user interface, once again, looks to have worked. It is putting things in the server that is going to create the output, and okay, let's go see what we got. Really? Don't troll me, you AI. Don't troll me. I know I'm mean to you. You know, I'll be mean to me. So there's that. Runs. Okay, so the first time we have it, it doesn't break. We like that. Now we go down here to the server, and we add the server below it. And server runs. Oh! Whoa, we got something. That's not what I want. But we do have something, and we do have the ability to select variables now. We're on the right track. I would start making it so that, especially if we're doing a categorical variable right here, this needs to be selecting only factors. We are looking at difference that looks to be means of desired weight, means of heights, probably what it's analyzing, and then the conversation just continues, and you try to push it towards what you want. But we do have an app right now with 2 tabs, which we can start working on, and selecting variables and an analysis button. So that's kind of the start of it. I didn't want to get too far, but I think that's a good 20, 30 minutes of like messing around and figuring out what to do. If you have questions, let me know. Bye for now. Bye, everybody. Bye.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!